my talk, Why I Can't Remember. My name is Keiko. I am from Japan. I am a scientist studying about memory, how it stores and records. You must have this kind of experience. One day you met a person who you know from your hometown. Yes, I remember her. We went to the same secondary school. She was good at math and she was very good tennis player. But what was her name? We had a chat, it was nice, but I'm still thinking what's her name. What is happening in the brain? Memory in the brain. It follows the next step. Step 1, learning and reconsolidation. Step 2, stored and maintain. Step 3, recall, remember, reconfirmation. Sometimes we can recall easily and clearly memory. Sometimes take time and sometimes hazy. Why? The memory is ambiguous. Even memory can be changed. Why? To think about why, let's look into the structure of a neuron. A neuron is a cell, therefore the basic structure of a neuron is the same as other cells. However, there are 3 unique features to neurons. First, a neuron has an extended cable, dendrite, and axon. Through these cables, neurons communicate with each other. Second, neurons use electrical signal to carry message. They are called spike. Neurons have a negative charge inside them and a positive charge outside of them. Spikes are positive sodium ion. Cell membrane separate inside and outside of neuron and have many holes for sodium ion. When these holes open, sodium ion can pass through the membrane and the neuron becoming less negatively charged just under the membrane. Neighboring hole open because of these changes in polarity, so that sodium ion wave, the spike, are carried out along dendrite to axon. The third, there is a tiny space between 2 neurons at the end of axon. It's so-called synapse. Spikes can't pass this space. Instead, they induce the release of a neurotransmitter. That neurotransmitter binds to the receptor in the next neuron, activating it. So spike induce neurotransmitter release from neuron A to neuron B. Why are our memory and thought ambiguous? Because the neurotransmitter release from synapses are not constant and it is probabilistic. It does not always occur when spike arrive at the synapse. Sometimes it releases and sometimes it doesn't. The probability for release differ between synapses. Each neuron is unique, with some synapses having different timing probability. Brain is derived by complex synapses. Total neuron in a human brain is estimated at 100 billion. We don't know exactly how many synapses there are per neuron, but it is estimated at 10,000. So total synapses in our brain is neuron times synapses, it's a lot. Creating huge networks, memories stored in these networks. There is absolutely crucial factor required for storage of memory in neuronal network. Neuron A and neuron B fire together, and then the connection between neuron A and B gets stronger. This is called Havian theory. When spike occurs at the same time between neuron A and B, then the synaptic connection gets stronger. The timing of these spikes is important. How can two neurons A and B know whether they have spikes at the same time? The spikes from the neck of neuron B is not only pass along the axon, but it is also flow back to the synapse. If a spike at the synapse in neuron A and another spike at the synapse in neuron B happen at the same time, then they can trigger change at the synapse. For example, the synapse becoming bigger and its receptors becoming more efficient. So the connection between neuron A and B gets stronger. These changes at the synapses are memory. I talked about the basic principle of how neurons communicate and create neuronal network. But this is simply work between neuron A and B. Remember, there are 100 billion neurons and each neuron has 10,000 synapses in our brain. Each neuron connects to another neuron, which, for example, sense emotion, smell, noise, sunshine. So there are so many factors influencing memory. I can imagine there is no same condition when we think same things. Sometimes we can't even remember what we are thinking. So memory is ambiguous. That's why I can't remember sometimes. But I think the ambiguity of memory is actually important part of being creative and imaginative for us. Thank you for listening. I hope you found this informative, and I'm looking forward to seeing you with any question you might have. Bye!